The distance formula is a formula actually derived from the Pythagorean theorem on the coordinate plane in order to find the distance between two coordinate points. Here is the distance formula. Basically, it's a giant square root, and under it we subtract our x's, then square it, subtract our y's, square it, add those two values together. We will get a number under the root. Either that number is a perfect square or it's not. If it's a perfect square, our answer is a nice integer. If our number under here is not a perfect square, we will simplify the radical at the end. Let's take a look at two examples. All right, we want to find the distance between these two coordinate points, -6, 7 and 3, 5. I write in the distance formula that we have to do the first x minus the second x and the first y minus the second y. This is not necessarily true, and some books might even put the 2 here and the 1 here. Because we're subtracting, the order that we subtract two things does matter. However, we're squaring what we get. So if we were to take -6 minus 3, we'd get -9, but then we square it. But what if we did 3 minus -6? We'd get 9, but then we'd square it. Either way, it would be 81 here. All right, let's plug in. Our distance formula starts with a long square root. Here we're going to subtract our x's. So I'm going to subtract them. -6 minus 3. I'll go in that first order. Then that gets squared. Then I'll just go in the opposite order for the y's. What the heck? Who cares? So I'll do my second y minus my first y to show that the order is not going to matter. So we'll do 5 minus 7 and square it. All right, to find the distance, let's simplify what's in each parentheses. So we'll have -9 in the first parentheses, and we'll have -2 in the second. No matter if we square 9 or -9, we still get 81. Here we'll get a 4. Move up here. So we'll end up having our distance is the square root of 85. We do want to see if 85 is, since it's not a perfect square, if we can simplify it at all. There are no perfect squares that are factors of 85, and therefore the square root of 85 is actually our final answer. We write it like this instead of writing its decimal equivalent because this is the exact answer. All right, here is our second example. We want to find the distance between the coordinate points 5, 4 and -3, 8. So using our distance formula, d for distance, we draw our giant square root. Then we subtract our x's, so we'll do 5 minus -3. And then we'll subtract our y's, so I'll do 4 minus 8. 5 minus -3 is 8. So I'm not going to put parentheses around the 8 since it's positive. Over here, 4 minus 8 is -4, so I do need parentheses. And we'll end up getting 64 plus 16 under our square root. And that brings us to the square root of 80. 80 is not a perfect square, so we do have to see if this can be broken down at all. And the square root of 80 actually can be broken down. Let's think about some perfect square factors of 80. 4 definitely fits into 80, but let's see if there's any bigger ones. 16 fits into 80. 16 and 4 are both perfect square factors of 80, but since 16 is the bigger one, that wins out. So 16 times 5 is 80, so we can rewrite root 80 like that. Square root of 16 is 4, so our final answer is 4 root 5.